So what is a computer? This is the week 1 presentation. As I discussed earlier, a computer is an electronic device. It can be programmed. Why? To accept data and then process this data. After processing the data, it will generate a result, or we call it output. Okay? So a computer consists of hardware, software. So the hardware and software, we call them a computer system. There is a difference between data and information. We said that computers process data into information. Data is a collection of raw, or we call it unprocessed items, such as text, numbers, images, audio, or even videos. So they are unprocessed. Information conveys meaning and is useful for people. So we process the data to make it useful, to make it information. Okay, so these are the sample. Here we have data, as you can see. We have some names, and then we have some information. Here we have also, like this is a receipt. Okay, so this is information. All right. So the data here on the left is processed in the computer. Okay, and information is generated. The information processing cycle inside the computer is divided into stages. So the computer will process the input data into output by carrying out or by executing some processes. We call these processes instructions. Okay? What is instructions? Instructions is nothing but the steps that you tell the computer in order to be able to perform a task. Okay? A collection of related instructions organized for a common purpose is referred to as a software. So we organize, if I have a collection of instructions to do specific purpose or task, we call this software. All right? And computer always or often holds data, information, and instructions in storage. Why? Because the computer will need it in the future, or the user might need it in the future. So this data and information is stored in storage. Now the series of input, process, and output and storage activities is the information processing cycle. Input, process, output, storage. This is the information processing cycle. Also, in the recent years with the technologies, we have another process, which is communication. Okay? Communication also has become an essential element of information processing cycle, and we all know why now. Okay? We need to send information, we need to communicate the data and the information. I'm going to run for you a video later on at the end of this presentation that will show you about the components of that are needed to assemble a computer, and I will show you some samples of input devices, output devices, and some of the internal computers on the motherboard of your computer. Okay. The computer system contains many electronic, and mechanical components. We call them hardware. The hardware consists of motherboard, processors, memory, input-output systems, which we call them basic input-output system or BIOS, and cooling systems. All these components functions together all these computers function together to deliver the desired output. Okay. How? they are communicating with each other. We will know later on because they have an operating system. Motherboard. What is the motherboard? The motherboard, as we call it motherboard, because it's the spine, it's the main part of the computer. Some people, they like to call it system board or main board. It's all the same. Okay? It is consisted of a printed circuit board or PCB. So you see this green board here. We call this BCP. Okay? And this one contains what? You see these lines? These lines are channels or buses to communicate between the parts that are installed on the motherboard. Okay? These components may be soldered. You use a soldering iron, you solder it to the motherboard directly, or you use sockets and expansion slots or ports. Okay. These are examples of the major components on a motherboard. We have the processor, microprocessor, we call it CPU, chipset, random access memory or RAM, ROM, cache memory, expansion slot connectors. We will show you this in the lab. Okay, so don't worry. Disk drive interface connections, standard I/O connections. Okay, so now let's talk about each one of these components. CPU. CPU stands for Central Processing Unit. CPU, it is the electronic circuitry that carries out the actual processing and is usually referred to as the brain of the computer. So the CPU is the brain of your computer. Okay. One second, please. All right. So this is the CPU. This is how it looks like. You see the image down there. This is a CPU socket. And then this is the CPU. You just install it here. Okay. The CPU is given instructions and data through the programs. And then the CPU will do the process or fetches the program and data from the memory and performs arithmetic logical operations. Okay. This is done by the CPU. The CPU by itself has three different or main components. It has the registers. Please, you need to know these names. Registers. The registers, they are used by the CPU to store the data as well as instructions in its local memory. This is called registers. Then it has also the ALU. The ALU performs all the arithmetic and logic operations as per the program. And then it has also the CU or control unit. It controls the sequential instruction executions, which one is executed first. Also, it interprets instructions and guide data flow through the computer's memory. Okay? Or through the ALU and through your I/O devices. I/O meaning input-output devices. Chipset. Chipset are microprocessor support devices that coordinate how system hardware interacts with the CPU and motherboards. We have two types of chipsets. We have North Bridge and South Bridge. North Bridge is high-speed, controls high-speed access to the RAM and video card. South Bridge allows the CPU to communicate with slower speed devices, such as your hard drive, because hard drives have some, especially the old ones, have mechanical parts, your USB ports and expansion slots. So it's called South Bridge. Input devices, we all know about input devices. These devices convert the input data into digital form that is accepted by the computer system. Okay? The data that is input through that is going through the input device is temporarily stored in the main memory, or we call it RAM, of the computer. If I need permanent storage, you can add additional storage such as secondary memory, and we will give you some examples for that. For example, for input device, I mean, anybody knows? Give me example of input device. Keyboard, mouse, microphone, okay, flatbed scanner, ADF, joystick, okay, that is used for games. This is also an input device. Keypad, input device. Camera, input device. What about printer? Output device. Screen, output device, right? Some of the new input devices is touch screen. So touch screen, it's an input device with touch or pressure sensitive screens. We have stylus, it's a digitizer. We have the magnetic strip reader, barcode scanner. You know the barcode scanner, you see this in the library. Webcams, signature pad, smart card reader, microphone. So these are all input devices. Also, we have NFC devices and terminals. NFC meaning near field communication. Like when you tap your credit card to pay, because it is using the NFC technology. Even your mobile, if you are storing your card data, credit card data on the mobile, it's using NFC technology. We have also the facial recognition scanners. We have fingerprint scanners, voice recognition, and other devices, such as the virtual reality headset also. Output devices like speaker. Output device, it takes the opposite, the binary information from the computer and convert it into a form that is easily understood by the user. It will take the digital data from the computer and present it to you like maybe print it on a paper or on the screen or on the speaker, you hear it, audio. So such as speakers, headphones, printers, monitors, and projectors. Computer memory. The computer needs memory to store the data and instructions for processing. Okay? When we talk about the computer memory, we usually are talking about the main or primary memory. The secondary memory is the storage actually memory. Okay? It is used to store the data permanently. We'll give you some examples. But first, let's talk about the units of memory. The smallest unit of memory is what? A bit. And a bit could be 0 or 1. So a bit is either 0 or 1. We call it a bit. A bit. Bit is a binary digit. And it is the basic unit of binary system. And the basic unit for the memory. If I have a block of 8 bits, it is called byte. Okay? Bytes are grouped together to make bigger chunks or units of memory. For types of memory, we have RAM, and there are differences between RAM and ROM. RAM is volatile, so if you turn off the power, the data on the RAM is gone, is erased. When you switch on the computer again, then you can use it. You have to store the data again. Okay, and it's called random access memory. So it works only whenever the computer is started or a software application is launched. And it is the main memory that is, and it is faster than by the way, the RAM is usually faster than the permanent memory or the secondary memory. We have also ROM, read-only memory. ROM is the opposite. It's non-volatile. So whatever is stored on the ROM, even if you switch off the computer, it's still there because it's non-volatile. It does not need power to save the data, to keep the data on. So it stores the computers also permanent startup programs stored there. We have also another type of memory. It's called cache memory. So we have RAM is faster than secondary. Cache is faster than, RAM is faster than secondary. But your processor is even faster. So you need, okay, to speed up the operation of your CPU. Then you need to put a very high speed memory between the CPU and the RAM. We call this memory cache, and it's more expensive than RAM, by the way. Okay. So if you look here in this diagram, I have the CPU, I have the primary memory. In the middle, I have cache memory. Why is it useful? Because it is reducing the average time required to access data from primary memory. So when the CPU needs to access memory, it first examines the cache. In case the requirement is met, it is read from the cache. Otherwise, the primary memory is accessed. So if it is stored in the cache, okay. Not stored in the cache, then it will go to the primary memory. The secondary memory, like hard disk, and the secondary memory is it volatile or non-volatile? Non-volatile, because if I switch off my computer, the data on the hard disk is still there, right? So it's non-volatile. Okay. It is slower than RAM, but it is cheaper also. In order to access the contents of the secondary storage, you need first to load it to the RAM, then the CPU can read it. Okay. Nowadays we have SSD, solid state drive. They are very fast. They have very fast data transfer rate. Okay. And now they are becoming cheaper. Before they were very expensive. Now, with the advancement in technology, they are becoming cheaper and cheaper. Now, the storage devices inside a computer connect to the motherboard using serial AT attachment connection. We call them SATA. This is one type of connection. Okay, so storage devices inside your computer connects to the motherboard using this SATA cable. This is an example of these cables. We have also inside your computer, we have adapter cards. And we have the expansion slots where you insert the adapter card. So why they are needed? They increase the functionality of a computer by adding controllers for specific devices and tasks. Okay, such as if I need, especially in the old days, if I want to connect speakers to my computer, I need to put a sound card. If I want to connect my computer to the network and I want to connect a cable, or if I want to use the Wi-Fi, I need to also install a card. You don't see this card in your laptop, but because it is built into your motherboard. But in some computers, especially the old ones, you can see the card actually. You can see a sound card. You can see a network card. We call it NIC. There is also video adapter. There is also universal serial bus or USB controller card. So computers have expansion slots on the motherboard to install adapter cards. And by the way, the type of the adapter card connector must match the expansion slot because there are different type of expansion slots. We will show you this, inshallah, when we do the lab. Then you have the case for your computer. We have different type of cases. And inside the case, you will have the power supply. You will have the power supply, the motherboard, the CPU, memory, disk drives, and all your adapter cards. The term form factor, this is an important definition. It is the physical design and look of a case. And such, for example, we have horizontal case. You can see the images here. Horizontal. We have full-size tower. We have compact tower, smaller. Okay. All-in-one. You see, you don't see the CPU here, right? You don't see the case. It's just the monitor. Inside the monitor, it has all the parts of the computer. And then you have the keyboard and mouse. Power supply. Why we need the power supply in the computer? To convert AC power into lower voltage DC that is needed by internal components. The power supply includes several different connectors, and they are used to power various internal components such as the motherboard, disk drive, DVD-ROM. In the old computers, we used to have like a DVD. When you connect, there's a connector for it. Okay. Or any other devices needed to get power from your power supply. Then you have also a cooling system. Why we need cooling system? Because computer components or semiconductors, they perform better when kept cool. We use active and passive cooling solutions. Active solutions require power. You need to connect something to it, like a fan. Passive solution, they don't need power. Passive solutions for cooling usually involve reducing the speed at which a component is operating or adding heat sinks to a computer chip. We will show you the heat sink, inshallah, in the lab. A case fan is considered as active cooling. Why? Because we connect it to power. But the heat sink, like the radiator, it will radiate the heat from the processor. I will answer your questions now. If you have any questions, these are the references.